Hello, welcome to today's GeoINT 2023 Lightning Talk. I'm Neil Kumar, Senior Product Manager at Ocient, and today I'm going to talk about leveraging in-database machine learning for geospatial forensic and threat prediction. Let's get into it. So imagine we're in a major city. In today's example, we're going to use Chicago, with an event occurring at a local city landmark. We're going to use Navy Pier in Chicago. We want to track and predict flying objects that might pose a threat to enter the airspace near this landmark. So the objective: can we build a model using previous flight paths and the time they spent in the airspace we define around the landmark of interest using just a data warehouse and SQL? How can we do this? So we're going to use a table of previous flight paths in the area and a table of zones as polygons for training. We can build a machine learning model to predict if a future plane or aerial threat that is being tracked will enter a zone based on its path to that point. Let's look a little bit deeper at the data. We're going to start with table 1, which is a set of paths that denote objects in motion. Each path is a set of points as a line string in an ST line string column. There's also a column, which is an array column of timestamps, where each timestamp in the array corresponds to each point in the line string of the path. In this visualization on the right, you can see a series of paths, and each path is a flight. It could be a plane, a drone, really anything flying through space. And in this example, they're leaving O'Hare Airport in Chicago. The second table represents our zones. They have 2 polygons representing our red and yellow zone. Each zone represents the airspace around Navy Pier in Chicago here, and they're stored as polygons in an ST polygon column in our data warehouse. Quickly, you can see a visualization of a few of the paths that actually do fly over these zones. We use them for our training to build the models. So let's start with our models. In the end, we actually want to use a feed-forward neural network, which I'll get to, but it seemed like a good idea to start by pre-processing with principal component analysis. We use PCA here to take 3 points, which would normally give us 6 input features, and reduce it to 2 for input to our neural network that are really a linear combination of the 6. On the left, you can see the SQL that we issued in Ocient to create this, which is a simple create ML model statement, which creates a model called PCA_model, which can then just be used like a normal SQL scalar function in our follow-up. Let's get to the meat of it. So here's our actual creation of the feed-forward neural network. You can see here that we're using the PCA model we created before to reduce the dimensions of input from 6 to 2. And after this is created, the model is usable as a SQL scalar function called time in red zone to predict if an object will enter the red zone based on the time it spends on the yellow zone. This can be used in follow-up queries on new data to make exactly that prediction. Finally, the real power of modern databases and data warehouses. Modern data warehouses like Ocient can enable analytics on geospatial data. They have support for native geospatial types like ST point, line string, polygon, multi-point, multi-line string, multi-polygon. And they have native functions for geospatial analysis. At Ocient, this is WGS84, spherical, math only, and geography types. Modern data warehouses like Ocient also include support for machine learning. You can build models right where the data is instead of moving it to a separate application entirely in SQL. This leads to faster iteration times, lower cost to build models, and you can train and deploy the models right where the data is for the freshest data that you have. And data warehouses like Ocient have support for numerous model types for supervised, unsupervised, and reinforcement learning, and even some deep learning as well. Finally, modern data warehouses like Ocient, they're designed for modern analytics. They have native support for spatial data that can empower organizations to find the needle in the haystack. And you can leverage machine learning natively to bring life to spatial data in your data warehouse without having to move it around, all in SQL. If you have questions or want to learn more, please reach out to me at Ocient. We can talk about geospatial analytics and database machine learning. My contact information is below at LinkedIn, and of course, you can reach us at ocient.com. Thank you very much.